am Afia Bruce, and I'm here lecturing on Csbg 261 Management Information System. This is lecture 8, and the topic is developing business systems. Developing business systems. We all know the way we are born as human beings and go through life processes, and then at the end of the day, life comes to an end. Natural systems follow this way in which a man comes to this life and then life ends at the end of everything. Systems, or let me say business systems, do go through these things as well. The evolution of any system made by or known to humankind begins at the point of conception and ends at disposal. Human-made systems are conceptualized, we plan them, we organize them, they are scheduled, we estimate them, they are procured, deployed, operated and supported, and then at the end of the day, it is disposed of. Just like I said, it is with natural systems. Natural systems do also follow similar constructs with life phases. We are born, we go through processes like live our lives, and then at the end of the day, we end our lives by dying. Business systems are like that as well. They come to place, we get them, we use them, then at the end of the day, they come to an end, we dispose them as well. So let me ask you this. Suppose your chief executive officer of your company where you work asks you to find a web-enabled way to get information to and from the salespeople in your company. If your CEO asks you to do this, how are you going to start? What would you do? Would you just plunge ahead and hope you could come up with a reasonable solution? How would you know whether your solution will be a good one for your company? Do you think there might be a systematic way to help you develop a good solution to the CEO's request? If your answer is yes, then it's as good as mine. In solving problems, there is a system to follow. We call it systems approach. There is a way, and this way it's a problem-solving process. As I said, it's called systems approach. When the systems approach to a problem-solving is applied to the development of information system solutions to business problems, it is called information systems development or application development. So when we say information systems development or application development, it is using a systems approach process to solve a business problem using information systems. The systems approach to problem solving uses a systems orientation to define problems and opportunities and then develop appropriate feasible solutions to response. Therefore, analyzing a problem and formulating a solution involve certain interrelated activities. These interrelated activities are: 1, you need to recognize and define a problem or opportunity using systems thinking. Then 2, you need to develop and evaluate alternative systems solutions. Then number 3, you need to select the system solution that best meets your requirements. Then 4, you design the selected system solution, and then finally you implement and evaluate the success of the designed system. We are going to go into these one after the other. Using systems thinking to understand the problem opportunity is one of the most important aspects of the systems approach. The essence of the discipline of systems thinking is that you see the interrelationships among systems rather than linear cause or effect chains whenever systems occur. You need to see or realize that the systems are interrelated. Then you need to also see the processes of change among systems whenever changes occur. One way of practicing systems thinking is to try to find systems, subsystems, components of systems in any situation you are studying. So you need to know the whole system. What other systems make up that system? What are the components of the whole system? You need to study these things. And when you do this, it is known as using a systems context of what? A situation. When you look at the system itself, what other systems are part of that system? What makes the system whole? We say the subsets of the system and then the components of the system. When you use this, we call it systems context of a situation. One method of using the systems approach to develop information system solutions is a process called the Systems Development Life Cycle. In short, we say SDLC, Systems Development Life Cycle. We'll look at a figure here and look at the stages that one needs to go through to develop a system, the cycle to go through to develop a system. The first one is investigation. Then you do analysis, you design, you implement, and then you maintain the system. It is important to realize, however, that all the activities involved in the SDLC, that is the Systems Development Life Cycle, are highly related and interdependent, meaning that they relate to each other and then they depend on each other. In actual practice, therefore, several developmental activities may be occurring at the same time, while certain activities within a given step may be repeated. As you develop the system, activities may be occurring at the same time. You might be doing one or two things at the same time, while certain activities would have to be repeated. We have said that you begin with investigation, analysis, design, implementation, and then maintenance. But sometimes, whilst analysis is going on, design might be going on. Sometimes, during the implementation stage, you might have to come back to the design stage. So, you might have to repeat some previous activities, and then you might also have to let the activities sometimes happen at the same time. This means that both users and systems analysts may repeat previous activities at any time to modify and improve a system under development. So those who are going to use, like the salespeople, the example that I began with, that your CEO will let you know what salespeople would need to work, and then using that data or information to come up with a system. You see, those people will say the salespeople will be the users. And then the systems analyst, the one analyzing the system, these two may repeat previous activities. They will work hand in hand to modify and improve the system under development. We'll look at the system investigation, the first one. We will look at something under called the feasibility studies. Because the process of development can be costly, developing a process does not come cheaply. It comes with a cost. The systems investigation stage typically requires the development of what? A feasibility study. And at this stage, there is a preliminary study where the information needs of prospective users and the resource requirements, the cost, the benefits, the feasibility of a proposed project are determined. When you want to build a house, you will not just get up and begin to build. You will sit down, you would have an architect look at the plan for you, you will look at the cost involved before you begin. So at the end of the day, before you build a system, you need to do feasibility studies. And this means you are looking at the requirements of what you are going to build, that is the system, what is the cost involved, is this going to benefit management, is it going to benefit the organization, and then a whole lot of things that should come to place to begin this project. So in doing this, a team of business professionals and information system specialists might then formalize the findings of this study that you have made in a written report that include preliminary specification and a developmental plan for a proposed business application. So business professionals and then IS specialists, that is information system specialists, would have to take this report and then look into it and then develop a plan to begin the process, or we say a proposed business application. So if they submit this to the management of the company and it is approved, the recommendations of the feasibility, the development process can continue. So if management approves the recommendations of the feasibility study, then the system can start, or the development of the process can start. Then we get to the second stage, which is called the system analysis. The system analysis is the process of understanding and specifying in detail what the information system should do. So the overall objective of the system analysis phase is to understand the proposed project and ensure that it will support business requirements and build a solid foundation for system development. So what is done at this stage is that models are used and other documentation tools are also used to visualize and describe the proposed system. Some of the questions that the analysis phase answers is that who is going to use the system? What will the system do? Where and when is it going to be used? So in the analysis stage, we are looking more deeply into the proposed system. Is it going to answer the questions that we need in this organization or this company? What will it do? What will it add up to the company? Which people are going to use it? So briefly, we'll say at this stage, the proposed system is thoroughly analyzed. Then we get to the system design. It is the process of deciding how the system will operate. That is in terms of the hardware, the software, and then the network infrastructure. The user interface, the forms, the reports that will be used, and the specific programs, databases, and files that will be needed. So this is where the system is going to be designed. And this place, it's done by system designers. They are going to look at how the system will work. How do we incorporate hardware and software? How is the network infrastructure going to be? What topology is the network going to be? How do we do the user interface? The place that users will interact with the system? What are the forms going to be used? What reports do we need this system to generate? The databases, the files that will be needed, the specific programs, and all that. This is the place that the whole system is designed. Then we look at the implementation stage. The implementation activities result in the final system being built, tested, documented, and installed. So what objective do we have here? The objective is not only to produce a reliable, fully functional information system. We are not looking at something that has been done and brought and we are going to use and it's going to help us. But also, we want to ensure that the users are all trained and that the organization is ready to benefit as expected from the use of the system. All the prior activities must come together to culminate in an operational system. So we are not just having a system, or your CEO has not just told you to come up with a system just to put it there to solve a problem. No. Those who are going to use the system need to be also trained, and that the organization should be ready, or we should see that the organization is benefiting as we expected from the use of the system, or as we expected from the beginning. When we did the feasibility, we analyzed it. So as the system comes to place, being used, those who are going to be using it need to be trained. And then under the implementation, we also have the testing. The testing is the process of examining the product or the system to determine what defects it contains. So you need to go into the system, and to conduct this test, programmers must have already constructed the software and have well-defined standards for what constitutes a defect. For programmers to come out with a report after testing the system, they would have to get a well-defined standard for which they are going to mark the work or the results that the system is bringing out with. They have to get a standard. If you don't have a standard, what are you testing against? What are you expecting? So they need to have standards of what they are testing the system against to be able to come out with what? A defect, or to be able to say that it is working well or it is short of this and that. Then we get to the support stage. The objective of the support activities is to keep the system running productively during the years following its initial installation. So the support activities begin only after the new system has been installed and put into production, and it lasts throughout the productive life of the system. You see, the system needs to keep on working well during the years that the organization is looking at the system to go. So we are looking at the start of the use of the program or the system, and then throughout the period that it's going to be used, we need to support the system. And the expectation for most business systems is that the system will last for years. We come up with systems, or we, if you are building, you want to build, and you are building and living in it for it to last for years. So even though we know that the system at the end of the day might come to an end, not an end that is not working, but there might be a time that we would need to upgrade, or we need to even build another one. But for the period that we are expecting the system to last, every or most business systems would want their system to last for years. So there are three major activities that occur during the support stage. You need to maintain the system. You don't build a system and leave it like that. You need to always make sure that hardware, almost everything that the system needs to keep on working or to keep on running productively. We build and we do renovations. So you have a system working in an organization. You don't leave it like that. You need to be maintaining it. And then you need to enhance the system. If software is being used, needs to be upgraded, you need to do that so that work will run well. And then you need to support the users. At the end of the day, whatever or whichever people are using the system needs to be supported, needs to get training. Almost all the time, their needs from the system has to be provided to keep the system running productively. We will move on to prototyping. When we talk of prototyping, it consists of building an experimental system rapidly and inexpensively for end users to evaluate. So by interacting with the prototype, users can get a better idea of their information requirements. The prototype endorsed by the users can be used as a template to create the final system. So what do we mean when we say prototyping or a prototype? The prototype is a working version of an information system or part of the system, but is meant to be only a preliminary model. Meaning, if you want to build a system, you need to build something we call a miniature, something to work with for the meantime to see how the system will look like. So we say you have a prototype of the whole system, a working document. Let me put it that way: a working document or a small working system, by giving you all aspects of the larger or the real system. So it's a working version, a working part of that information system or that part of the system, but it's meant to be only for the beginning, just for a while, for you to know how the bigger system or the whole system will look like or how it will be working with it. So that is what we mean when we say a prototype. Once operational, the prototype will be further redefined until it conforms precisely to users' requirements. When you build that working system, that small working system, that is going to be used for a while to see how it is going to look like before we finish it up to become the whole system. Once it starts to work, that system will be further redefined until it meets the requirements of the users. The users would have to come out with problems they are facing with that working document or that small miniature, how do I put it, that working version of the information system. The users would have to work with it, the problems they will encounter, things they would want to get out of the system, things they would want to be added to the system. They would have to come out with all these things so that when we have come out with the problems they are facing or the needs that need to be put in the system, then we build the whole thing with what they have come out with. So once the design has been finalized, the prototype can be converted to a polished production system. As I said earlier, it is just a temporary working document of the whole system. We are using it, or we say we have a prototype of the whole system so that users will use it and then come up with what should be added to it or be taken from it. So once all these things have been done, once we put in their needs or we take out the ones that are of a problem to them, the prototype, once it has been finalized, can be converted to a polished production system, the real system that is now going to be used. The process of building a preliminary design, trying it out, refining it, and trying again has been called an iterative process of systems development. The reason being that the steps required to build a system can be repeated over and over again. It is called an iterative process of systems development because, as I said earlier on, when the system prototype is being used, users have that opportunity or that space to come up with how the system it's like being worked with. So when they come up with problems, the system developers would have to go back and look at the problems they have and then fix it, let them use it again until they come up and say it is okay. So that is what we mean when we say it is an iterative process. That is, the system can be repeated over and over again until the prototype is converted to a polished production system. So let's look at the steps in prototyping. The first one is that you identify the user's basic requirements. The system designer, usually an information system specialist, works with the user only long enough to capture the user's basic information needs. So what does the user needs basically to work with the system? So what the system designer does is that he would have to work with the user long enough, give the user a while, and then be able to capture what the user basically needs, or capture the user's basic information needs. Then two, after you have identified the user's basic requirements, you develop an initial prototype. The system designer creates a working prototype quickly using tools for rapidly generating software. So you need to quickly come up with something. Now you know what the user needs or requires. So you come up with an initial prototype, an initial temporal working system. Then three, you use the prototype. The user is encouraged to work with the system to determine how well the prototype meets his or her needs and to make suggestions for improving the prototype. As I said earlier on, this is a temporal work or working document of the whole system. So the user needs to be encouraged to use it. We are not saying you should be perfect. So you need to encourage the user, just use it as it is, and tell us the issues with it. Tell us the problems you are going through with it. That is what we need from you. So encourage the user to work with it, to be able to know what to add to it or what to take from it. And then the step 4, you revise and enhance the prototype. The system builder notes all changes the user requests and refines the prototype accordingly. So the user will definitely come up with whether this, if you can improve upon this, how do we use this? If I use this, this happens. You see, the user will definitely come up with, it is the first time the person is using the system. So most definitely the person will come up with issues, problems, things the person would want the system designer to add to the system to make it very flexible to be used. So if the user comes up with these things, then the designer would have to revise and enhance the prototype. The designer needs to note all the changes the user requests and then refines the prototype based or according to the request that the user has made. After the prototype has been revised, the cycle returns to step 3. So now if there are things that need to be added or taken out of the system, then after doing that at step 4, the system builder or the system designer would have to go back to step 3. That is for the user to use the enhanced prototype again. If the user comes out with issues again, then the system builder would have to let the user use it, and then he would have to revise and then enhance upon it again. Go back to third and then comes back to 4. That is, let the user use the prototype, and then when suggestions are made, the builder will revise and enhance it. So at the end of the day, steps 3 and 4 are repeated until the user is satisfied. So you'd have to let the user use it, come up with issues, revise and enhance it, let the user use it again, and until the user is satisfied to work with the document. Let's look at the advantages of prototyping. The three major advantages of prototyping are that the potential for changing the system early are one, the potential for changing the system early in its development. You see, if care is not taken, you might change the whole idea that began with the building of the system early. At an early stage, if you are not careful, the system has not gone through a lot of stages. But by using the prototyping, you might tamper with it or change it so early. Then the second one, the opportunity to stop development on a system that is not working. You would have that opportunity to stop developing the system that is not working. If the system has problems at an early stage, you will know it and then stop working with it. You wouldn't waste your time building the whole thing before you change it. You would change it as early as possible because the problem with the system will be identified early. And then the last one, the possibility of developing a system that more closely addresses users' needs and expectations. When you use prototyping, you will be able to know what the users' needs are and what the users expect. So you'll be able to address these needs and expectations more closely because the user will use it, come up with suggestions, and then you will enhance it. The user will use it again, come up with suggestions, and then you enhance it. So at the end of the day, you see that the needs and expectations of the users are addressed more closely. Then the disadvantages of prototyping are that one, the first is that it can be quite difficult to manage prototyping as a project in a larger systems effort. If the system is a huge one or a large one, when you begin with a temporary or just a small working part of it at the beginning, if you are not careful, it will be quite difficult to manage it because it is a large system, and then the prototyping is just some part of it. It will be quite difficult to manage it because you can't have, it can't be that small or that easy to work with that small document or that temporary thing with what the larger system. And then the second disadvantage is that users and analysts may adopt a prototype as a completed system. One thing is that when users begin to work with a prototype of the whole system, they kind of adopt the system. And when they cannot use it anymore or it is enhanced, it becomes difficult for some of them to use it because the system might not in fact be adequate, and the prototype might not be what was intended to serve the finished system. So when it becomes like this, users and analysts find it difficult to adopt the prototype because what they are used to, or adopt the whole system, the finished system, because what they are used at the end of the day might not be what the whole system was intended to be like. This is the end of today's lesson. Thank you